Hello and welcome to this new YouTube video. My name is MrGrey and I'll be taking you through some entertainment. In today's video, we're gonna again do a few crazy simulations in our solar system and see how the system reacts. The last simulation we're gonna do is actually something we might, for real, witness in real life. So enjoy the video. The first thing I'd like to do is a simulation on the sun. What if the surface temperature, or the temperature basically of the sun, was negative? Now, based on Universe Sandbox, the surface temperature is 5,500 degrees. And what would happen if we change that to minus? What if the temperature of the sun was minus 5,500 degrees? Is this something possible at all? Let's find out. To simulate that, all we need to do is add a minus to this number. And look what's gonna happen. Yep, the very first thing we notice, our sun shuts down. There's no more glowing and definitely no heat coming out of the sun. The second thing we notice, the temperature became minus 273 degrees, not minus 5,500. Let's try this again. Let's do it like minus, I don't know, 1 and as many zeros as it goes. Again, it will be stuck on minus 273 degrees. The reason is this temperature is the coldest temperature recorded in our solar system. Scientists name this temperature the absolute zero, and that's because even atoms freeze at this temperature. There is no way in the universe things can get colder. This is the coldest temperature things can be. Let's head to our planet Earth and see what is happening there now that the sun has been shut down. Okay, the first thing we notice is a glitch, I think. Yep, this should be a glitch from Universe Sandbox. And we still have a bright side on the planet, and that doesn't make any sense. The sun is nowhere to be found because it's not glowing. We can't find it. Sun is a star, and now it's shut down. I think the developers of Universe Sandbox need to work in that little detail. We can't have a bright side. But still we're gonna... Okay, that's the sun. I found it. See? That is the sun. And even the bright side is wrong, but we're gonna ignore this little detail. This is from Universe Sandbox. I hope developers will work on that. What we really need to know is how are we doing on the planet? Okay, the average temperature of our planet is 7.6 degrees based on Universe Sandbox. It dropped a little bit, which is logical because we are not getting any heat, but here's a little piece of information. If this happens in reality, if the sun shuts down, we are not going to know that before 8 minutes. That's because the light takes about 8 minutes to reach us from the sun. So yeah, if the sun shuts down, we will only know that after 8 minutes. However, let's speed up time a little bit and see, are we gonna freeze? Are things gonna get colder? Logical answer, yes. And that is going to happen fast, by the way. So, yep. Now take a look at the upper right corner here. Our planet is turning into a ball of ice. If we go to the composition and scroll down to what's called life likelihood, it's dropping too. It was about 96% and now it's dropping really fast. Let's speed up time even more and see what's gonna happen in the future. We are now in year 2320. That's in 300 years, and just now, likelihood turned into 0. There will be life, or some kind of life, let's say, will survive for the next 300 years. That's what the simulation is telling us. But the temperature will reach, the average temperature of our planet will reach minus 226 degrees. Now, some of you might wonder, how come we did not freeze at once? And why 300 years? I think this is logical, the simulation is logical. That's because our planet has heat from the inside. So until it has consumed all the heat in the inside, well, there's definitely no heat from the outside because there's no more sun. But it will take the planet about 300 years to consume all the heat from the inside. And by that, the end of all kinds of life. This is planet Mars. We terraformed this into a habitable planet in a previous video. If you still didn't watch it, you can hit the exclamation mark on the upper right corner to watch it. However, what I would like to do, what if the dwarf planet Pluto hits the planet Mars? What is the result going to be? Let's find out. Now we're gonna add Pluto, go to launch, and that is Pluto. Let's take some distance and hit it. Alright. Now, before this happens, let's just get Pluto to get really, really close to Mars, and then before it hits it, let's pause the time. Alright. Is this looking good? This looks good. Turn the flashlight on, go to Pluto. Why Pluto? Why do I want to do this simulation? If we go to Pluto, in the compositions, we can see that Pluto has water. It has actually a decent amount of water for a dwarf planet, which is 34.2%. I can imagine this clash of titans is going to come up with something. I paused the time because I don't want that to be a huge crush. We don't want to crush Mars using Pluto. So I'm gonna go to motions and I'm gonna set the speed of Pluto to 0. Like this, we will just give the gravity to chance to work. These two planets will hit each other using gravity only. Let's slow down time a little bit. We want them to gently touch each other. Okay. Now it's getting even faster. That's because of the gravity of both planets. Okay. Yep. Fragments are shooting out of Pluto. The gravity is doing that. And that's what I wanted to see. That's what I actually expected to see. We can see water. Water is spreading on the surface of Mars. There definitely is going to be heat. Now look at that. We're going really slow in time. The temperature of Mars is raising. It's raising really fast. Okay. I don't want to go super fast. We want to see a nice simulation. Look, the planet is covered with water. And at the side where the collision happened, look at that. The temperature is about to reach 500 degrees. It's 450. Okay, there are white clouds, we can tell. Planet is covered with water. Mars got itself a thicker atmosphere. How do I know it's atmosphere? We just go to visuals, hide the atmosphere. Here, the planet is covered with oceans, full of water. It's still so hot. But here's a question. Are we going to see life growing when this planet gets colder? I mean Mars? Let's find out. Speed up time. Okay, we have now... It's still getting colder, but we have now planet Mars with thicker atmosphere. Show me what's happening on the surface. Highest temperature 51, lowest is minus 38 and dropping. Is there life likelihood possibility? This is crazy, but when Mars got cold, we have 8.67% chance of life. Now let's turn the vegetations on. Crazy. There are green vegetations on the planet. This is crazy. All we did was hitting Mars. Can we see light? City lights? I don't think so. I don't think civilization is gonna grow on the planet. There's no way we're gonna see civilization, no. My god, look at that. There are city lights. We only hit Mars with Pluto. And after some time, after the planet got colder, there is life. What about the life likelihood? Is it gonna raise? Is it gonna drop? I don't know. But for a short period of time, definitely there will be civilization. It's even raising. This is beautiful. Well, we could have done that in the first place when we terraformed Mars, but wait a minute, now things are going in the wrong direction. The temperature is dropping really fast, green vegetations are hiding, and definitely life likelihood will drop. Okay, this is beautiful simulation. I love it. Okay, let's speed up time for real and see will there be still life on the planet. Okay, it's freezing. All right. Atmosphere on. Flashlight on. Okay. The planet Mars still has its atmosphere. Life likelihood is still at 8.5, let's say 8.5%. Temperature is okay. Average temperature will be, like you see, it's going up and down. There will be life, but not life as we know it. It can't be humans' life, maybe some kind of creatures, I don't know, unicell or whatever they called. Definitely not humans, because yeah, there are no liquid water. They all the water freeze, and with that, no city lights. City lights are gone. But we created life on Mars only by hitting it with Pluto. This is beautiful. In the next two simulations, we're gonna do something special with the star UY Scuti. Until 1990, UY Scuti was considered to be the largest star discovered in the universe. Let's add UY Scuti first and have a better view. Okay, this is UY Scuti. Now, in 1990, they discovered Stephenson 218 or whatever it's called, and it's larger. It's a bit bigger than UY Scuti. But before 1990, UY Scuti was the largest star discovered. To understand how large this star is, okay, keep in mind it's more than 1,700 times wider than our sun. To understand exactly what that really means, let's add the sun next to it and show you what I mean. Okay, this is good. Now, this is our sun. Okay, look. This is our sun. This is UY Scuti. This is a huge star. What I would like to do is this. What if in our solar system we had UY Scuti instead of the sun? Like we said earlier, it will take the light 8 minutes to reach us from the sun. How long do you think it will take the light to reach us from UY Scuti if it was in the place of the sun? To simulate that, first let me turn the trails. Okay, turn the trails on. Let's go far from the sun. This should be good, and we will stay here. Now keep in mind, I'm not going to change my location. We can see the sun, it's really far, but how will it look like if it was UY Scuti instead of the sun? Let's go to actions, replace object, and find UY Scuti. Okay, that's UY Scuti. Now once I hit replace, things will get really weird. We did not change our location, we did not go closer or further from the sun. All we did was replacing the sun. And that's how our solar system looks like. This is crazy. You might be wondering, where are we, planet Earth, and how long will the light take us take to reach the planet Earth? Okay, ladies and gentlemen, we vanish. We literally vanished. UY Scuti swallowed our planet. Now, normally, the average distance between Earth and Sun is about 150 million kilometers. But if we had UY Scuti instead of the Sun, it's so big that it's gonna even swallow all the planets up to Saturn. And now in this new solar system, the first planet, the closest planet to the star is Saturn. Can you imagine what we're talking about? This is really crazy. Okay, let's see how is Saturn doing so close to the new star. The average temperature is still cold, but if we speed up time, look at that. The planet is cooking. Saturn is cooking. And now if we take a general look at all the objects in the solar system, they're all glowing. And heat is going to be super crazy. Now here's something. Saturn is heading one direction, and that's to the heart of UY Scuti. Look at that. It's gone. The gravity of UY Scuti swallowed Saturn. And look at all of these explosions. It's swallowing everything in this solar system. Let's speed up time even more and see where that ends. Now, at the end of this simulation, this is obvious. The UY Scuti is swallowing each and every object in our solar system. Look at that. These are all dwarf planets and well, not dwarf planets. They are just random asteroids, very at the edge of our solar system. And they have all been swallowed by UY Scuti. Now, these are the last two objects. Speed up time. Okay, one object managed to orbit the UY Scuti. This is funny. Oh, okay. Let's go really close. Wait a minute. Let's slow down time a little bit. There's only one, it's called Sedna. I have no idea what that is, but I know that it's at the edge of our solar system, and it's the only thing that managed to orbit UY Scuti. Everything else became part of UY Scuti. In this last simulation, we're gonna simulate the death of UY Scuti. Now, when stars this size die, they don't just go gentle, they don't die gentle, they make mess in the universe. And the death of UY Scuti is going to create what's called supernova. Scientists think we can see this supernova from the surface of our planet without even needing telescopes. We can see that with our bare eyes. They also know that UY Scuti is an old star and it's living the last period of its default life. Maybe it died already, but we still cannot see the reaction of its death because basically UY Scuti is 9.5 million light years far from our planet. And if not already dead, it's definitely going to die within 10,000 years from now. So who knows, maybe one day we wake up and we see a supernova in our sky. So now let's try to simulate the death of UY Scuti. Unfortunately, in Universe Sandbox we cannot actually land on our planet Earth and take a better look. This is possible in Space Engine, but not in Universe Sandbox. So basically, let's say from our planet, this is how UY Scuti looks like. It's a bright little dot. Now what we need to do is explode this star. UY Scuti, 3, 2, 1, bam! It's gone. Where's the supernova? We still cannot see it. We're gonna speed up time and see and wait. Are we really going to see a supernova like scientists promise us? They say we can see that with our bare eyes, we don't need telescopes or something. Now all we do is speed up time and wait to see something changing in our sky. Alright, ladies and gentlemen, we have spotted something. See that? That's a supernova. Look at that. This is the death of a major star. Look at that. Let's speed up time even more to see, is the supernova going to grow even bigger? Yes, it is. Wow. What a beautiful view. Okay, slow down time. This is how the death of UY Scuti might look like from our planet Earth. Now I'm gonna slow down time a little bit so we don't go really crazy. Yeah. Isn't that beautiful? Imagine one day waking up and actually seeing this in the sky. Is this not something really beautiful? Yeah, they promised us we might look at that, see that one day. Let's speed up time even more. My god, the supernova is even growing bigger and bigger. It's still really far. It looks so close to Earth, but it's actually really still so far. I love this simulation. I like it. I personally like this simulation really much. This is probably my favorite simulation so far. Write me in the comments section below if you like this kind of simulations, please. Let's head to this supernova and take a closer look. We can't unfortunately go inside, or can we? Oh yes, we can. Okay, we can. We are inside of this supernova now. And this is basically where once was a UY Scuti. Our entire solar system, now this is not just the sun, this is the entire solar system. It looks so humble compared to this supernova. So we have come to the end of this video. I really hope you enjoyed watching. If you want me to do specific simulations, please feel free to write me that in the comments section below. Don't forget to like the video, subscribe to the channel, and I will be seeing you in future videos.